Hey everybody, if you're watching this, then I didn't make it. I'm still not feeling well. I have a fever and a nasty cough still. So I'm going to try and make it back tomorrow. But let's go over this practice. I know you guys rocked the bingo, had a good time. We're working on this. I just want you to have it out and have a pencil out and be making corrections and things as we go. And I'm not going to show every single problem. Some of them are pretty straightforward. I want to show you a couple that are a little less straightforward. But first, let's do one that's more straightforward. It's just show all of your work. So what you really need to be doing here is showing every single piece. So this one we're minusing 4 on both sides. We get A equals, excuse me, 7. And then your check. 7 plus 4 equals 11. 11 equals 11. Check. I gave you lots of room on each of these. I took out problems. That's why it goes 1, 2, 3, 10, 11, 12, 16, 17, 18, because I wanted you to have room for all of this work. So let's take a look at number 12. This has decimals, but no reason to freak out, right? Because we're just going to get rid of 7.1, and it's the same thing. We're just subtracting. So n equals 8.6 minus 7.1. So that's 0.5. That's 1.5. And then our check, 1.5 plus 7.1 equals 8.6. You can even do your math in the corner. $8.6 equals 8.6. So totally doable, not a big deal. Some of this fraction one too, also not to freak you out, because really we're just getting rid of, we're minusing 5/12. Since I have 12ths over here, I can subtract 5/12, right? These cancel out. I'm left with P equals 7/12 minus 5/12. Leaves us with 2/12 or 1/6. And then if I correct it, 5/12 plus 2/12 equals 7/12. 7/12 equals 7/12. Boom. Okay. If you reduce this and put 1/6, that is also glorious. It's probably preferred. Okay. This one here, though, a little bit different, right? Because you can't just subtract the thirds. So what do you need to do? You need to find a common denominator. So I'm going to change these thirds into sixths. So I'm going to times by 2. I'm going to rewrite it down here. Negative 2/6 equals negative 5/6 plus u. Now I can get rid of my 5/6 over here. Add 5/6, add 5/6. You've got to follow your rules. Same signs add and keep, different signs subtract. So I'm left with 3/6, and that's positive, equals u. And if you reduce that to 1/2, that's great. But I would leave it when I go back in here. If I go back to my original, that's always my suggestion, but you're going to have to find that common denominator anyway. So I'm going to go back to this equation right here and plug it in. Negative 2/6 equals negative 5/6 plus 3/6. Negative 2/6 equals negative 2/6. So that works out there. So that ends up being your answer. All right, the last one, of course. Let's take a look at that one. It says the sum. What does sum mean? It means plus. When we add those all together, the sum is 360 degrees. I love geometry. I can't wait to break some geometry off for you later. But one thing is, we know that the sum of all of these angles is 360 degrees. So if I add these all up, it's going to equal what? 360, right? If I add all of them up, so let's add all of them up. I've got 100. Kind of back it up a little bit for you. What else have I got? I've got 110. I've got 80. And I've got D. I don't know what D is, but you know what? It doesn't matter because I can figure it out. First of all, I'm going to combine my constants here. 1, 2, 280, 290 plus D equals 360. 360. Now, I know you can solve this by taking 360 and just repeatedly subtracting those. I know you can solve that because it's kind of what we're doing as well. But this says write an equation and then solve the equation algebraically, okay? So I'm going to subtract 290. Duh, that's how I would do it if I wasn't writing it in the expression this way, although it is kind of giving order to my thinking, right? 360 minus 290. So that's 70 degrees. So D equals 70 degrees. And let's go back and check it. I could go back to this one right here. This is really the equation that's simplified. So 290 plus 70 equals 360. Let's make sure I did this right and I didn't put you astray. Yep, so 360 equals 360. I just went back here and wrote 290 plus 70 equals 360. Just did a check. So your answer is 70 degrees. So you just wrote it as a sum because we're adding them all together. All right, head to the back of your page. On the back of the page, we've got some other stuff that gets a little bit chunkier here, the division and multiplication. So, okay, right here we're going to multiply by the inverse, actually the reciprocal, but negative 11 over 1, negative 11 over 1, k equals 33. Because negative 3 times negative 11 is that. So I have 33 over negative 11 equals negative 3. And that is indeed negative 3 equals negative 3. You got some space over here too. So if you can't squish it in, you could do your problem here and your check here. Not a big deal. Okay, let's see. Most of these are pretty straightforward. Let's look at number 6. I'm going to be dividing by negative 12 and dividing by negative 12 because negative 12 divided by negative 12 is 1. And that's being multiplied by k. So that's 1k. That leaves us with k. Negative 60 divided by negative 12, 5. Sorry, my brain is not working. All right, so let's check it. Negative 12 times 5 equals negative 60. 510, 56. Yep. So we are good to go. So you can do your check over to the side if you like. Most of these are straightforward. I'll do this one again. Times 5 over 1 times 5 over 1. These cancel out, leave us with y equals 5 times 15, 65. And then we check it. 15 equals 65 divided by 5. 15 equals. I wanted to make sure that I've got 5 times 5 is 25. Oh, that's not right, is it? That would be 75. 5 times 5. Yeah, this should be 75. Do you see what would have happened? I would have gotten 15 equals, I think this would have been 14 times. And that would have not been right. So I had to go back to my check. 75 divided by 5. Again, I apologize. I'm not using all of my brain. So let's see. 65 divided by 5 equals 13. 15 times. Okay. So let's head over to this one. Again, just multiply by the reciprocal. And this is really important for today. We're going to be doing a lot of multiplying by the reciprocal. It's just that there's going to be a little bit more of a reciprocal. There's going to be a little bit more of a fraction happening here. So this is m equals 18. 9 equals 18 over 2. 9 equals 9. Man, I hope I make it through this lesson and don't steer you wrong because my brain sure is it's like 10 o'clock and it's going, ah! Levon sold 4 times as many raffle tickets as Kenneth. Levon sold 56 raffle tickets. When it tells us two things, that they're equal. What Lavon sold is what Lavon sold. So if you talk about like using a bar, Lavon sold this entire amount, and she sold 56 raffle tickets, right? And she also sold 4 times as many as this dude, Kenneth. So we'll put K in here. So 4Ks is the same as 56. So we can write that out. 4K equals 56. And then we can go ahead and solve that way. Divide by 4, divide by 4. Okay. So this is, excuse me. So you can use a bar method like this before you set up your equation to really think it through. I always like to think of it as a picture. Or you can say 4 times as many as K, which is 4K. We did a lot of practice that way, is the same as 56. And you can set those equal to each other. So that's up to you, whatever you'd like to do with that. All right, friends. Open your, actually take this paper with your name on it, and if you could give it to the substitute, they're going to collect it from you while you're getting out page 457. I would just like to see, I'm just going to maybe sneak in, see what you had, how you're doing. I want you to turn to page 457 while that's happening. And we're going to talk about solving equations with rational coefficients, which sounds really scary, but it's not scary. It sounds really smart. Solving equations with rational coefficients. But it really just means fraction. Sorry. All right. Paper should be collected just about. We're working on 457. Actually, I'm going to have you switch over to 458. Okay. On 458, we're doing some things. They show an example of how to solve a coefficient with the decimal coefficients. And you've already did a little bit on your homework of decimals, like if we're adding and subtracting decimals. It's the same exact thing. I didn't talk to Mrs. Nugent and Mr. Gross, but there's a possibility you're not using calculators on this, folks. You're actually dividing. We haven't done a lot of practice on that this year yet. But today, since I don't have the word about that, we'll go ahead and use our calculators. But if we take a look at these examples, and of course I'm going to give you one to put in your margin because no one's paying attention to the example. Maybe some of you are. So we have the equation itself, and then you're just dividing both sides by 0.25, just like you would a normal multiplication coefficient expression, an equation. You would just divide both sides by 0.25 because that cancels it out and leaves us with n, and n would equal 64. And then, of course, you're checking. See, they're actually showing the check here. That question mark means, is it really equal? And if it is, we're good. Okay? So in your margin, why don't you go ahead and put this problem down? And then we'll do some problems together. $1.6K equals 3.2. Now, because this is, you're just writing this right in your margin. Because this is a decimal, you're just going to divide by 1.6. We've got K equals 3.2 divided by 1.6, and that is 2. And then you would go ahead and check it. 1.6 times 2 equals 3.2, and 3.2 does indeed equal 3.2. So that would check out on that one. So we're doing it the exact same way. What I want you to do now is go ahead and work on, I just want you to do B. I just want you to do B. I feel like you've had a lot of practice on it. Go ahead and do B. All right, we're going to divide both sides by what? Negative 2.8. It's got to be negative because we want, I almost wrote 1.8, because we want negative divided by a negative to be a positive 1. That gives us P equals 4.2 divided by 2.8, and the answer is a negative 1.5. Let's go ahead and check. Negative 2.8 times negative 1.5 equals 4.2. Negative 2.8 times 1.5 is indeed positive 4.2. So you're good there. All right. Same things we've been doing this entire time. If you're having a difficult time after having a lesson, having a semi-review, having another review yesterday, and now going on to this lesson, then you are really going to need to jump onto ConnectEd, get onto the internet, do some more practice, get in your book, do some more practice, watch some more videos, practice, because we're not going to move any slower. We're going to keep going. We're going to assume that you've mastered this. I'm going to give you a skill check on Friday to show you've mastered it. So we'll have another day of practice, but it really is your responsibility to get to Ag Lab at an ICU with your homework, to get to Ag Lab in the morning, to talk to somebody. I know I'm not available these couple of days, but get in with Ms. Nugent or Mr. Gross or somebody who can help you out to practice this, okay? Because it's your responsibility to make sure you've learned it. Okay, let's take a look at number 2 here, this example, because really you're not only just going to be solving these, but you're going to be writing your own equation. So if we're talking about writing our equations, we have to think about this as an algebraic sentence. So Jay's coach agreed to buy ice cream for all of the team. Ice cream cones are this much each for every ice cream cone. Write and solve an equation to find out how many cones the coach is going to buy with $30. So I have $2.40 times, I don't know, the number of ice cream cones they're going to get, because they're going to get each one, equals 30. And we're going to see if it does equal 30 or how many we can get. If you come up with a decimal, then clearly you have to round down because they can't get a whole ice cream cone. But that's $2.40 times every single cone they get. And that's going to give us how many is going to be in $30. So we're going to divide by 240, and you get N equals, let's see what they give us here, 12.5. And you would go through and check, but first you're going to simplify, okay? Well, 12.5, can they get 13 ice cream cones? No. Like normally we would round up with 12.5. But if he only has $30 in his wallet, then he can't round up. He can't get 13 ice cream cones. He's going to be out $1.20. So he has to round down and say, I can get 12 ice cream cones. I want you to try D, please, letter D. Suppose the ice cream cones cost $2.80 each. How many cones could she buy with $42? It's the same exact equation with some different numbers. Get after it. What I'm seeing here is it's $2.80 for every ice cream cone. And this time, he's got $42 to spend. So instead of dividing by 240, we're going to divide by 280. And I get N equals 42 divided by 280, which equals 15. And you don't have to round on that. It's an exact number, 15 ice cream cones. And of course, do your check. 2.80 times 15 equals 42. And it indeed does equal 42. Okay, those are pretty straightforward, except maybe for the word problems for those of you who can or cannot see those. So let's take a peek now at the one that's going to give you the most trouble, but it's really not that bad. It's really not that bad. You have the skills, and you'll see why I've been writing my inverse, my reciprocal, as a fraction and not just as an integer when I've been multiplying to try to get rid of these division signs. So if I'm looking at 3/4 x equals 12 over 20, in order to get rid of this 3/4, like I know that 3/4 times 4/3, I can cross those out, it equals 1. Just 1. So that's what I'm looking for. I want it to be just 1x, right? Excuse me. I want it to be 1x. So guess what? If I'm trying to get rid of that 3/4, then I have to multiply each side by the reciprocal. So flip-flop that. I've got 4/3. Flip-flop it on this side, because anything I do to one side, I have to do to the other to keep balance. And then we can, the words I'm always forget, cross-cancel. Yay, that wasn't too bad. We can cross-cancel. So these cross-cancel, and I get x equals, and then let's see, I've got a 3 and a 12, so that's 1 and a 4. Got a 4 and a 20, so that's 1 and a 5. So I really end up with 4 times 1, which is 4. 5 times 1, which is 4/5. So my answer is 4/5. So I can go back in here and say 3/4 times 4/5 equals 12/20. 3 times 4 is 12. 4 times 5 is 20. I'm not even showing you my check, am I? I really need to pay more attention to that. So I just 3/4 times 4/5. And you know, multiplying in fractions is awesome. You just multiply the top and the bottom and you got it. Okay, let's do another example. In your margin, I want you to do this one. I guess we can look at this one down here. Okay, so I've got -7/9 d. Now, these are coefficients. These are multiplying. Okay, it's not like d is up here in my numerator or down here in my denominator. This is 7/9 times d. Okay, so only difference here is I have a sign that I have to pay attention to, right? So I'm going to multiply by the reciprocal. It's still negative, but it's -9/7, because that way I can keep my sign. Over here, these cancel out, and d is left with d by itself. So now I have 5/1, really, right, times 9/7. There's nothing I can cross out here. So 5 times 9 is 45. 1 times 7 is 7. So my answer is 45/7. And of course, if you want to get it into our simplified version, it's -6 3/7. And of course, you go through the check. So you do 45/7 times -7/9 equals 5. -45/7. And then it's got some big thing here. So -3 15/63. The -10's negative is a positive, and it ends up being 5. So let's do a couple of these. Let's do E, F, and G before we go any farther. I want you to practice multiplying by the reciprocal. E, F, and G. Dr. Pepper. Help me, Dr. Pepper. A very healthy example for you, is okay, let's take a look at these. You might not be all the way through all of them, but okay. I'm multiplying by the reciprocal. I'm kind of going to rewrite this here so that that E is not in my way. I know you don't have the pleasure of that, but I'm going to go ahead and do it. Okay. I'm going to multiply times 2/1 because that's the reciprocal of 1/2, right? Which really is just 2, right? So I'm getting rid of that. I've got x equals 8 times 2, which is 16. Here's my check. 1/2 times 16, which really is 1/2 of 16, equals 8. and 8 really is. What happens 16? Okay. All right, let's try the next one over. Negative 3/4 x equals 9. I'm doing f now. Okay. Aha! Multiply by the reciprocal, but it has to be a negative because a negative times a negative is a positive. Whoops! Look, I just made a mistake. Don't do that. You catch it on your your check, but don't do that. Okay. So these are going to cross cancel, and I'm going to end up just with x. And then this can cross cancel too. 1, 3, because this really is 9 over 1. 3 goes in there once, and 3 times here. 3 times 4 is negative 12 over 1, which is really just negative 12, right? And let's go ahead and do this one. Negative 3/4 times 12, negative 12, excuse me, equals 9. So 12 times 3 is 36 over 4. And it's not negative anymore. I'm sorry, it's positive because a negative times negative is positive. So 36 over 4, which actually is 9. 36 divided by 4. So that looks good. Your answer is negative 12. Last one, negative 7/8 x equals negative 21/64. We are multiplying by the reciprocal, which is 8 over 7, negative, of course. Negative 8 over 7. So these are going to cancel out and give me positive x. And then over here, I've got 1 and 3. And I've got 1 and 8. 8, right? 8 and 8 went to the store to buy Nintendo 64. Yep, that's right. 3 times 1 is 3. 8 times 1 is 8. And my x is 3/8. So, excuse me. 7/8 times 3/8 equals negative 21/64. 7 times 3 is negative 21. 8 times 8 is 64. And that's the same as negative 21/64. So we are correct with 3/8. You guys getting the hang of this? It's really not super tough. You already know how to do this. I don't know how I'm doing on time here, but usually how I'm doing on time is not great. Let's see if it gives me a time. Sorry, I'm trying to look to see if I've got a time up here, but I don't see one. That's okay. Okay, here is your homework. Your homework is page 461, 1 through 8, and page 463, 15 through 21. Let me get it. Oh, for the love. Okay. Page 461, 1 through 8, and page 463, 15 through 21. I need you to show all of your work and do a check. Everyone say it with me. I will show my work, and I will do a check. Thank you so much. Those are required for full credit because we're focusing on the process, not on the answer, right? Right. Any monkey with a calculator and a brain can get those answers. But you, my friends, are better than that monkey. You are doing algebra. Okay. Love you guys and miss you tons. It's been like a week since I've seen you now. So I hope that you have a great rest of your day. And I will be back tomorrow to go over these with you and answer any questions while we review for the skill check.